all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, try your best to answer this question, and come back when you're ready for the answer. We're going over in 3, 2, 1, let's go. What is a parent function? Hopefully this is a term you've heard before, but in case you haven't, we're going to go over it right now. A parent function is the simplest form of a family of functions. The simplest form of a family of functions. So essentially, that means it's the most basic form of a type of function. So if we had a linear function, if I asked you, okay, what's the simplest form of a linear function? A lot of you watching would probably say, oh, well, that's y equals mx plus b. But that is not the parent function. That's not the simplest form. That's slope-intercept form. It's sort of a formula almost that helps us graph linear function, but it's not the simplest form, but it can help us get to what the simplest form is. So let's think about this. M is the slope. And let's think of this. What is the simplest slope we could have? Well, that would just be 1. And then if we said, okay, now let's move on to B. What's the simplest B? What's the simplest y-intercept we could have? Well, that would be 0. So if we plug in 1 for M and 0 for B, we get y equals x. And that is the parent function. This is the simplest linear function we can get. All other linear things, we can sort of think of all other linear functions as being transformations or adjustments to the parent function y equals x. Now, an absolute value function, the parent function would be y equals the absolute value of x. All absolute value functions start from there, and then, we either add something or multiply. They get more complicated, but that is the simplest form, the parent function. Now, there's lots of different types of parent functions that we're going to be dealing with, but now you know what they are. So chapter 4 is all about quadratic functions and equations, and we're doing 4-0. This section we're going to cover today is actually not in our book. It's sort of a preliminary section that I think will be helpful as we go through this chapter and subsequent chapters. But anyways, after today we should be able to translate parent functions. Translate parent functions. So today we're going to be doing translations, which hopefully you remember from geometry, or when we take something and we move it vertically or horizontal, or we could do both at the same time and end up with a diagonal translation. But that's what we're going to be doing. And to do this, we're going to start with, okay, the most basic parent function that can be y equals f of x. We don't know what f of x is, but whatever the function is, it's just f of x. That's what we're starting with. And in order to translate this vertically or horizontally, we would have to add or subtract numbers to this. Now, depending on where we add or subtract the numbers, we can get a different type of translation. And what helps us figure out what type of translation we're going to get is this formula right here. Y equals f of x minus h plus k. Now, before we get into the specifics about what h and k do, it's important to notice where they are. The h is inside the parentheses. It's inside the function notation, which means that our h value is whatever we add or subtract inside the most important part of the function. It's inside the most important part of the function. K is outside the parentheses. It's outside the function notation, meaning the k value is whatever we're adding or subtracting outside the most important part of the function. That's going to be really important as we move forward. Let's start with k. K is a vertical translation. It depends, or it determines how far we move our function up and down. So if it's f of x plus 5, here we've got a plus 5 outside the most important part of the function, we just move up 5. It works exactly how we think it would. And then, okay, if we've got a minus 5 outside the most important part of the function, then we move down 5. That's it. H works a little bit differently, though. H is a horizontal translation, so we're talking about left or right here, and it moves the opposite direction of what we think. And what I mean by that is, okay, if we had a plus 5, if we're thinking, okay, left or right, and we add 5, well, normally, that would be right 5. Adding 5 moves us to the right on a number line. But in function notation, or rather, when we're translating a function, if we add 5 inside the most important part, we actually end up moving left 5. And similarly, if we subtract 5 inside the most important part of the function, instead of moving left, we actually end up moving to the right. So h works the opposite of what we would expect. And it's very understandable for students to look at this and say, well, why would adding something move to the left? It doesn't make any sense. Well, the short answer is it just kind of works that way. But I'm not satisfied with that answer. So let's dig a little bit deeper and figure out, okay, why does h move a function in the opposite direction of what we think it should? So what we're going to do here, we're going to take a look at two functions, y equals x squared and y equals the quantity x plus 1 squared. And we're going to see how this changes. So essentially what we've done here, we've added in a 1. We're adding 1 into the most important part of the function in the parentheses there. So before we square it. So let's see how that changes our output values, our y values from the parent function. So here our parent function is y equals x squared. So let's see. Let's start with 0. So if I plug in a 0, well, 0 squared is just 0. Plug in a 1, 1 squared is just 1. Plug in a 2, 2 squared is a 4. 3 squared is 9. And then the negatives, plug in a negative 1 squared is positive 1. Negative 2 squared is positive 4. And negative 3 squared is positive 9. So there we've got all of our output values, our range values, our y values. Those all mean the same thing. We have all of those values for our parent function. But now let's see what happens if we add a 1 here. So I like to think of functions as, it's almost like an assembly line. So like first thing, our first function machine, all it did, we gave it a number and it squared it and it spit out a different number. But now we've changed it to x plus 1 squared. So before we can even get to the most important part of this function, before we can square anything, we're adding a 1. We added an extra step into our assembly line for this function. And let's see how that changes things. So let's start with 0. So before we square it, it becomes 0 plus 1. That's 1. 1 squared is 1. All right, now let's do the positives. So for the 1, we plug in 1. 1 plus 1 is 2. 2 squared is 4. For 2, 2 plus 1 is 3. 3 squared is 9. And 3 plus 1 is 4 squared, and we get 16. Now let's worry about the negatives. So negative 1 plus 1 is 0. 0 squared is 0. Negative 2 plus 1 is negative 1. Square that, we get positive 1. And negative 3 plus 1 is a negative 2. Square that, we get a positive 4. Let's look at the two different y values we have in our chart. The y values up top, and what happened to that 9? There should have been a 9 there. Did I not write that? Oh, well, we'll just leave it in. Now let's go back to looking at our output value. So we're comparing this row to this row. Hopefully you're noticing that all of the output values got moved to the left 1. So adding 1 inside the most important part of the function, adding 1 before we get to the squaring or the absolute value or whatever is whatever's the most important part of the function, adding a 1 before we do that actually ends up moving all our output values 1 to the left. So you just have to keep that in mind that h just works backwards of what we expect, and hopefully you see that I'm not just making this up. And actually, we can sort of observe this with the function. All right, so let's jump into some examples here. That was a lot of talking. So in example 1, you don't have to write down the whole graph. If I were you, I would just sort of write down, the function that we're dealing with. So the function is y equals the absolute value of x minus 3 minus 2. And the parent function is y equals the absolute value of x. That's what we have graphed here. That's the parent function for an absolute value. And then, let's see, our h value is a negative 3. That means we're moving right 3. And let me put it right under here. So this means we're moving right 3. That was supposed to be an h. I'm not sure what happened there. Right 3. And we've got a negative 2 for a k value. So that means we're moving down 2. Remember, h is always the opposite of what it looks like, and k, we just follow the sign. So we move right 3, 1, 2, 3, and then down 2, 1, 2, and there we go. We took our parent function and we translated it so that it would match the function absolute value of x minus 3 minus 2. Move right along to example 2. Scroll down a little bit here so I can see the rest of the examples. So it's y equals not the absolute value, y equals the quantity x plus 4 squared plus 1. So again, our h value is whatever's inside the most important part of the function. So that would be the plus 4. Remember, h would do the opposite of what we would think, so that means we move left 4. So we're going to move left 4, and then for the positive one, that's our k value, so we just follow what it looks like, and we go up 1. So let's see, left 1, 2, 3, 4, and up 1. We just translated our parent function to create a new function. Example 3. We've got y equals the absolute value of x. I don't know why I keep saying absolute value. Y equals the square root of x minus 5 plus 7. Again, the parent function is y equals the square root of x. Now, you may not have seen a function like this before, a radical function, a square root function, but who cares? The beauty of these translation rules is that they work for every single function you're going to see. So every function we see in Algebra 2, you can use these translation rules. On any function you see next year in pre-calc or the year after that in calculus, every new function you're going to see will follow these same translation rules. So hopefully this isn't like too difficult right now. Hopefully this is making sense. But the reason we're spending so much time in this is because once you learn these rules, the rules stay the same for every function you're ever going to run into. Well, most functions. Maybe there's some weird exception I can't think of off the top of my head. There's a lot of math out there. Anyways, I'm getting distracted. So our h value, it's an x minus 5 inside that square root, so that's going to mean we move right 5. So we're going to go the opposite direction of what we would expect for h. And k is a plus 7, so we just go up 7. And let's see that. So right 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6, 7. And there we go. Just a few more to do. So now we don't have a graph, and it's just saying to describe how the graph of a parent function would be translated to create the function y equals sine the quantity x plus 3 plus 4. Now again, you probably remember, well, hopefully you remember sine from last year in geometry, but even if you didn't, how do I want to say this? In geometry, you probably didn't go over what the graph of a sine function would look like, but it doesn't matter. You know, we follow the same rules. Even though we're not sure what this is going to look like, we know, okay, once we have our parent function, we're to translate this, this plus 3 would make us move left 3. So left 3, that doesn't look like a left 3. And the positive 4 outside, that's our k value. We're just going to go up 4. That's it. So even though we don't know exactly what the graph's going to look like, we know how to get to our function given the parent function. Now we've got same directions, but it says y equals 1 divided by x minus 2. Now this can throw students off because you probably haven't seen a function that looks exactly like this before. So I'm going to give you a little hint here. The parent function is y equals 1 over x. The parent function is y equals 1 over x. So now that I've given you that hint, try this one on your own. Pause the video, come back when you have your answers. We're going over 3, 2, 1, let's go. So this negative 2 is an h value, or it's in the place of h. So that would mean that we're going right 2. And that's it. Our h value is a positive 2 here. So we're moving to the right 2. That's it. There's no, like we don't see a positive 5 out here or anything. There's no k value. So we don't translate it vertically at all. We just move to the right 2 and we're done. Last one for this video. And again, I'd like you to try this one on your own. Pause the video, think about it, come up with your answer, then we'll go over it together. 3, 2, 1, let's go. It's y equals 12 plus x squared, so the parent function, it's a quadratic, that's just y equals x squared. Now, a lot of students get confused by this because the 12 is in front. They think, oh, that's got to be an h value, but it's actually not. The 12 is a k value. We're going to move up 12. Now, in case you're not sure why that is, just remember, the h value is whatever we're adding or subtracting inside the most important part of the function. The k value is whatever we're adding or subtracting outside the most important part of the function. The most important part of this function is the power of 2. So that 12, that's not inside that's not inside the squared with the x. You don't see like parentheses around the x and the 12 or something like that. Oh, this would be a better way to show it. It's not like we see that. That would make 12 an h value because it's inside the most important part of the function. But there's no parentheses, so that means 12 is just a k value. We go up 12 and we're done. Hopefully that made sense. If you have questions, by all means, let me know. Enjoy the rest of your day.